To verify this trig identity, we need a common denominator since we're adding fractions. And hopefully you can see that the left fraction needs cosine and the right fraction needs 1 plus sine of x. So when I multiply cosine times cosine, I obviously get cosine squared. The next one, lots of errors came when people just squared each term, but that's not truly what's happening. We have to FOIL this, just like any other kind of polynomial. So we have 1 when 1 times 1 is multiplied, 2 sine of x, and sine squared. And in the denominator, this truly is common. And all this must equal 2 secant x if it's to be true. Another trig identity from the unit circle comes from cosine squared and sine squared equaling 1. So we can replace these with 1. And now this 1 and this 1 makes 2. So I have 2 plus 2 sine of x all over that same denominator of cosine x times 1 plus sine of x. And now hopefully you can see that there's a 2 in each of these terms. And so I can factor that 2 out and get 2 times 1 plus sine of x all over that same denominator, which conveniently has 1 plus sine of x in it. So that can be canceled out, leaving 2 over cosine of x, which is exactly equal to 2 secant x, since secant is 1 over cosine. So you've completely verified this identity, but in order to do so, you'll need all of those steps.